DNS Exam 2, problem number 16. In this one, they tell you right off the bat, this is actually the first thing here, that if the substitution u is equal to the square root of x minus 1 is made, so we're actually starting with that, then this integral right over here on the left, the integral from 2 to 5 of the square root of x minus 1 over x with respect to x, is equal to, and they don't actually want us to evaluate this integral, they just want us to make the substitution. So, they've already given us the primary right here. Here we go, at the square root of x minus 1. So as we move on down to the next line right here, we know here that we're going to have a definite integral. We're still going to have a fraction. And that numerator, the square root of x minus 1, is just going to become u. So that was pretty simple. But the hard part here, of course, is going to try to come up with the secondary substitution, the leftovers here, and that's going to be a little bit tougher to do. So the way that we normally handle a u sub problem without thinking real hard is after we write down what u is, we go ahead and we differentiate both sides of that equation. So we're going to get that the derivative of u is equal to, and let's think about this, this is x minus 1 to the 1/2 power. So its derivative with a 1/2 power is going to put a 1/2 out in front. That's a 2 on the bottom. Then the x minus 1 is going to get taken to the negative 1/2 power, which becomes a square root down on the bottom. 2 times the square root of x minus 1 times the derivative within, which is just going to be a 1. So again, that derivative is going to be 1/2 x minus 1 to the negative 1/2 times 1, and we'll put a dx at the end of all of that. Now that doesn't look like it's anything here that we were looking for in any regard. So that is a bit of a mess right there. We want to try to handle that one in a way that is going to cover everything we have here in the original integrand. So let's take a look at what it is that we could do with that. The x on the bottom right here and then the dx that we have right here really don't look like they're going to go together very well. So I'm going to do something I very rarely do, which is to take this denominator here on the right-hand side and multiply it up here on the left. So that's going to give us a 2 times the square root of x minus 1 multiplied by du is equal to a dx. Now the reason we hardly ever do that is because we have a mixed metaphor right here of x's and u's. But lucky for us, if we go back here to the original substitution, the square root of the x minus 1 is just u. So we could write this as 2u du is equal to a dx. Okay, so this dx right here then can be replaced by a 2u and a du. So I'm going to put a 2u up here in the numerator. I'm going to put a du at the end of all this. And then the one thing we haven't talked about yet is the x right down here on the bottom. Okay, so to do that, I'm going to actually take all of my work right here that we just did. I'm going to slide everything down just a bit, and I'm going to do what we occasionally do, which is to go up a level from here to try to solve for x in terms of u. Squaring both sides, we're going to get a u squared is equal to an x minus 1, and then adding 1, the x is going to equal a u squared plus 1. So this x right down here on the bottom now can get replaced by a u squared plus 1. Okay, it's ugly, but that's where we're at. And the one thing we haven't talked about yet are the limits of integration, and it's been a while since we've discussed this. But let's remember that the original limits of integration, 2 and 5, are values of x. We now need them to become values of u, and we're going to do that by taking these two numbers and putting them right in over here for x in the original substitution. And as dumb luck would have it, they chose these numbers carefully. Putting in a 5 minus 1 is 4, and the square root of 4 is going to be 2. Putting the 2 in there now, 2 minus 1 is 1, and that square root is going to be 1 as well. So it looks like we could do a little bit more to clean up this integral right here. Looks like it's a definite integral from 1 to 2, and then the u times the 2u up on top is going to give us a 2u squared up there in the numerator, and in the denominator we have just a u squared plus 1 and a du at the end of all that. And it looks like that is one of our choices right there. As I'm looking at the 4 options right here, yep, it looks like B is our correct option right there. Little sneaky on their part. A was almost the exact, actually it was the exact same integrand, but on A they didn't change the limits of integration from 5 to 2. So A had a 2 here and a 5 here, so you got to be careful about that one. Okay, so the correct answer here for number 16 was B.